here you go. You don't need me standing in the corner anymore. So we're looking at electric forces and electric fields. First thing we got to do is look at the structure of an atom, of a very simple atom, basically a hydrogen atom, except this one, we know that that's not a real model of an atom. We don't really know what they look like internally, but this is our model so far. And we also have the new, the of subatomic particles. The standard model is not this, but these numbers are very important. Okay, mass of a proton, mass of a neutron, mass of an electron, and the basic charge. Okay, this is the basic charge, and it's in coulombs. It's kind of like in Sesame Street where they had your word of the day or something. Today's lesson is brought to you by the letter C and the word coulombs. All right, which is a base unit of the base. That's how we measure charge. Is we measure it in coulombs. And notice the charge on a proton and the charge on an electron are identical. Their masses are completely different. A proton is supermassive. It's 1.6 times 10 to the 27 power. An electron is roughly around 1 times 10 to the 30th power, negative 30th power. So you've got 1.627. It's 10,000 times bigger. Ballpark. Okay? If I divide these two, it's huge how much bigger the proton is than the electron. It's like a ping pong ball to an elephant almost. All right? Well, probably not quite that big, but it's massive. A proton is hugely massive, but their charge is the same. The only difference, positive charge, negative charge. Okay? And so that way we can quantify how much charge how much extra protons we have, or how many extra electrons we have to protons in a certain area where we notice a charge. Okay, and we get that by this. This is Q is equal to NE. And so here's what we do. Let's do a sample problem real quick. Sorry, small delay here. There we go. Sample problem looks like this. This is lecture 1 notes. Got a better pen than that. There we go. I like that a little better. All right, so lecture 1 notes look like this. Hairy hand. Apologize for that. All right, lecture 1. The amount of charge, Q, is equal to the number of extra protons or electrons times E. So we should actually say Q is equal to plus or minus N times E. If we're talking about extra electrons, or we're talking about extra protons. We usually use a small q or a large q. They're interchangeable. There's your first equation from E and M. Not that hard. How do we use it? Hopefully in the next slide there will be an example of how we use it. Okay, how many electrons are there in 1 coulomb of negative charge? So, if Q is equal to 1.0 coulombs, positive, how many protons are there? What is N? That's what we want to find out. Well, that's not hard. 1.0 coulombs is equal to N times 1.6 times 10 to the negative 19 coulombs. Remember, N is going to be a number, so the units are canceled. 1.0 coulombs divided by 1.6 times 10 to the negative 19 coulombs. This would be something we'd have done in class together, but I'd much rather do a homework problem or something like that. And so you're going to get a big number. I'm sorry, I was all ready to go, but I have my calculator. Whoops. And I just went through all those things. I'll show you. See, I'm out of practice. I'm out of practice. I used to be really good at this, but now I've kind of gotten out of practice here. We got 1.6. So I'm going to take 1 divided by, okay, here's how I do these. I take 1 divided by, parentheses, 1.602. We'll go ahead and go second e to the negative 19, close parentheses. We're going to be using lots of small numbers in this class. And so when we're using lots of small numbers, you want to make sure that when we're using small numbers, we want to make sure that you use the parentheses. Boom, 6.24 times 10 to the 18. Yada, 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 times 10 to the 18. Notice no units. Okay? All right. So that's how that works. Now, when we charge objects, let's go to a charging, let's go and look at a charging video. Okay? So out here right now, the end of